The story of the Channel Tunnel, or Chunnel as it's often called, is one of human ingenuity, determination, and a deep desire to connect two nations, France and England, that had been separated for millennia. This separation dates back to the last ice age, around 8,000 years ago, when the melting ice caused sea levels to rise, turning the low-lying land bridge between England and mainland Europe into what we now know as the English Channel. For centuries, this body of water posed a significant challenge to travel and trade between the two regions. Despite being only about 21 miles wide at its narrowest point, the channel was a formidable barrier, often fraught with treacherous weather and unpredictable tides. The idea of creating a fixed link between England and France was proposed as early as the 19th century, but it wasn't until the late 20th century that this dream began to take shape in the form of an underground tunnel stretching beneath the sea, 250 feet below the water's surface. The construction of the Channel Tunnel was no ordinary engineering project. It was an endeavor of epic proportions. The decision to build the tunnel was finally made in 1986, following decades of debate, political negotiations, and planning. The project was monumental not only in its scale, but also in its complexity. Digging a tunnel under the seabed where tons of water pressure could collapse the structure at any moment required precision, advanced technology, and a high level of coordination. A single mistake could lead to catastrophic flooding, endangering lives and potentially scrapping the entire project. To tackle these challenges, it was decided that two separate tunnels would be dug simultaneously from both the English and French sides, with the goal of meeting precisely in the middle of the channel. This method required the utmost accuracy, as even the slightest misalignment could prevent the tunnels from joining seamlessly. One of the most critical components of the project was the tunnel boring machines, TBMs, the colossal devices responsible for digging through the earth. These machines were custom-built in the United States, each weighing around 1,100 tons and measuring nearly 800 feet in length. The TBMs were a marvel of modern engineering, designed to cut through the chalk marl beneath the channel with incredible precision. Their rotating cutter heads, equipped with hundreds of steel teeth, could carve out tunnels as wide as a 4-lane highway, advancing at a rate of around 250 feet per day. To give you an idea of the scale, each of these machines was so large that just transporting them to the construction sites was a massive logistical challenge. The TBMs operated deep underground, digging through the earth while simultaneously laying down a series of precast concrete segments to form the tunnel's lining. These segments, or steel slabs, were an essential part of the tunnel's structure, providing the strength needed to withstand the immense pressure from the overlying rock and water. Each slab weighed about 40 tons, roughly equivalent to the weight of 8 Burj Khalifa skyscrapers stacked together, a testament to the immense forces the tunnel needed to resist. As the TBMs bored through the earth, workers installed these slabs behind them, creating a reinforced waterproof tunnel as they advanced. The process was slow and painstaking, with each machine carving out a circular path through the seabed. Despite the challenges, the TBMs pressed on, driven by the knowledge that their work would forever change the connection between the UK and mainland Europe. The project's engineers faced numerous challenges along the way, including geological surprises, mechanical breakdowns, and the need for absolute precision in the alignment of the tunnels. As the two sides inched closer to each other beneath the channel, anticipation grew. People from both nations watched eagerly, waiting for the moment when the two tunnels would finally meet. However, the final breakthrough was far from simple. Aligning two tunnels being dug from opposite directions, miles apart, was a monumental task. Engineers relied on a sophisticated laser guidance system to ensure that the tunnels would meet at precisely the right point, both horizontally and vertically. After years of relentless work, the moment of truth arrived on December 1st, 1990. Deep beneath the English Channel, French and British workers broke through the final wall of rock, separating their tunnels. It was an emotional and historic moment. After decades of planning, construction, and overcoming countless challenges, the two nations were finally connected by the longest undersea tunnel in the world. The TBMs had done their job, but their work was not over. One of the machines, having fulfilled its purpose, was left buried deep within the ground. Its sheer size made it impossible to remove, and destroying it posed too many risks. Instead, it became part of the tunnel itself, a silent testament to the engineering marvel it had helped create. The completion of the Channel Tunnel was celebrated with great fanfare. It was a moment of pride not just for France and England, but for the entire world. The tunnel officially opened on May 6, 1994, with a ceremony attended by Queen Elizabeth II and President François Mitterrand. The total cost of the project was around £9 billion. Despite its high cost, the Channel Tunnel was hailed as one of the 7 wonders of the modern world by the American Society of Civil Engineers. It was a symbol of what human beings could achieve when they combined vision, technology, and sheer determination. Today, the Channel Tunnel is an essential link between the UK and mainland Europe, used by millions of people each year. It has significantly reduced travel time between London and Paris to just a little over 2 hours, transforming both tourism and commerce. Let us know your thoughts in the comment section. Thanks for watching. Subscribe to the channel for more such amazing videos.